Thank the gentleman. Chairman Biggs, you're recognized for 5 minutes.
Thanks, Mr. Chairman. Again, thanks to all of you for being here today. And Dr. Brun, can you please explain some of the environmental benefits of super clean CO2 power cycles?
Basically, what you're doing here is you're providing a power cycle that's more efficient, and that's the first generation of supercritical CO2 plants. So just by a 3 to 5, sometimes 7% efficiency of a power plant, you're really reducing all criteria emissions by that percentage. The next generation of supercritical CO2 plants, which is really what we're looking for, is the holy grail of supercritical CO2, is oxy-fuel combustion, and that leads to a potential for a completely carbon emissions-free power plant, because what you end up doing is you are getting a 100% concentrated stream of CO2 at the end that's already pressurized, and so it's ready for sequestration. So the short-term goal is really an incremental improvement of efficiency and obviously reduced power cost and cleaner power. The long-term goal is completely carbon-free power plants.
It leads me to wonder, you must see a path to that. I mean, obviously you don't know all the technologies and answers, but you do see a path to the holy grail, I guess.
Yeah, we have a development roadmap, and that's coordinated between the different industries. And it's really been a very, very positive, collaborative industry, academia, and government process over the last 8 years. We've really moved the technology forward over the last 10 years. Normally, in the power generation side, it takes decades to move any technology forward, and we've really moved supercritical CO2 in the last 8 years from concept to power plant technology. So we similarly have a roadmap to get ourselves to oxy-fuel combustion, which is that next level of supercritical CO2 plant. I would say we're about 5 to 10 years away from that, and there needs to be continued aggressive funding, both from industry and from government, to achieve that. But right now, I think there is a clear path toward that.
Okay, so when you talked about in your testimony today, you said we're on the verge of commercial viability. Where in that path do you see commercial viability coming in if we're, what, 5 to 10 years away from oxy-fuel combustion?
Right. It depends on what type of oxy-fuel or supercritical CO2 plant you're looking at. So supercritical CO2 plants at the lower temperatures, for example, for waste heat recovery, those are now commercially available. They have been, you can now go to General Electric or you can go to other companies and say, sell me one, and they will sell you one. That was not the case 3 years ago. That was certainly not the case 8 years ago. We're trying to get to that same level on other technologies, like, for example, concentrating solar power, higher temperature supercritical CO2, so more for fossil-type applications, maybe in the next 3 years. Oxy-fuel combustion is probably going to take 5 years. So some is already commercially available, and some is not. And so there is a development path that we need to follow, really toward higher temperatures.
And so what regions of the country or what areas do you see benefiting the most from this technology?
There's really no limit there. This is widely applicable. The nice thing about supercritical CO2 is that it's siteable anywhere, and it doesn't have any water requirements, and that makes it really siteable in places where there is, where you have to have access to water.
Like Arizona, I'm thinking.
Arizona's fine.
Very good. Thank you. With that, I yield back, Mr. Chairman.